They came up with 17, by studying motion pictures, 17 motions. And they called them Thurbligs. And Thurbligs are Gilbreth spelled backwards, except for the T and the H. So Heather, if you can give me the next slide, there are effective Thurbligs, and the effectives are reach, move, grasp, release, etc. And there are ineffective Thurbligs. Next slide, ineffective Thurbligs. Search, select, position, you can see them. I got connected with this when I had a video of my golf swing, and my instructor said, you have a lot of ineffective Thurbligs in your golf swing. But it is also important to me that's kind of an important event that this award is happening in Puerto Rico. Because in my career, I remember in the mid-1980s coming down to Puerto Rico to recruit graduate students for Penn State. And I started to meet some of the faculty at Maiguez. I remember Jack Allison was the department head, and I also met Jose Zayas. Jose Zayas became a very, very close friend of mine over the last 25 years. My school, Penn State, and then Northeastern partnered with the University of Puerto Rico at Maiguez, with the Learning Factory, with the Engineering Research Center we had at Northeastern, and I had such great rapport, and still do, with the people in this island. Have been really great people to work with. They taught me a lot how to get along with. So I also want to recognize Jose Zayas, who actually nominated me for this award. Jose, I see you sitting up there. Why don't you raise your hand? Thank you, Jose. Now, if I could just say a couple more words about contrasting life 50 years ago versus today. What's different and what's the same? I hold in my left hand an instrument that a few people might know. How many people know what this is? Oh, a few people do. How many people don't know what it is? It's a ruler of some case, in a case. So back in the 1960s, a slide rule was used to solve problems. Now, this is how we use problems now, with an iPhone. And this is a hell of a lot better. So the technology has changed dramatically. What hasn't really changed, maybe this is subject to some other review, but all my career, I spent most of it in academia, we have been trying to figure out why students choose industrial engineering and how to exploit that somehow for their good and for our good. And I served in some administrative capacities up until this year. Now I'm teaching a course, and I'm dealing with undergraduate students. I have 77 students in an engineering economics exam, or course. We gave an exam today, and I've had an opportunity to speak with a lot of them. And it's amazing to me how similar, when I ask people why you chose this major, it's always this holistic view of our careers and the breadth of opportunities that are happening. One thing, however, is different. Where I'm at in Boston, a significant number, about 40% of my students are international students, and many, if not most, from emerging markets, from Latin America, South America, Middle East, Indonesia, etc. But the students all seems to be the same story as many of us when we chose industrial engineering. So I think, in my view, the greatest opportunity for our institute is to leverage this kind of international global interest in our profession. People know JFK. JFK was the president when I went to college. So I just put this in perspective that so I span a large number of years. And we all probably have went through a process, I can remember vividly, about choosing an engineering major. As we all have. Everybody's went through that process of how you came to the conclusion of choosing an industrial engineering as a major. I remember as a freshman 3 things. Number one, we had somebody show a picture, a little graph, a matrix of the transportation problem, which many of us know. And I identified with that problem because they were shipping railroad cars of coal from places like Scranton and Wilkes-Barre and Berwick that I knew about. So somehow I thought this would be something that, because where I lived, there was lots of railroad cars going through Altoona, and I knew that was a fairly big deal. I remember also learning how to program in Fortran. Of course, in those days, you used to punch cards. People don't remember this, but you punched cards, and you went to the computer center, like you put down your hope, you submitted something, and you'd hope it would work, you'd come back. At any rate, the thing about Fortran programming that amazed me, really, was how a program could change itself. I was just entranced by the fact that you could write a program and it could change itself as it went through a day. So those two things were talked about as something industrial engineers know about. The third thing I remember was on sort of the other side of the fact. As an engineering student, back a long time ago, everybody took a lot of engineering graphics. We drew with T-squares and all this kind of materials that we had to make engineering drawings. And the first course I ever took was an engineering graphics course, and the instructor gave us this little quiz. And it was these kind of things where you see a top, side, and front view of something, and then there were 4 choices. What was it, A, B, C, or D? And when I took that, first we had 25 questions, and I got 6 of them right. And the instructor said, Al, don't be disappointed. After this course, things will be different. So I took the same kind of exam after the course, and I got 4 of them right. So I figured mechanical engineering wasn't going to be a big winner for me. So with those kind of experiences, I ultimately moved to industrial engineering, and I've been involved with this field, with people, with systems, with people. It's been a wonderful, wonderful experience for me.